When I was first asked to present today, I was actually asked by Anna Martin to kind of consider a little bit why it is I'm interested in design in relation to science. And I have to say, I don't think that's a particularly easy thing to answer. Though I would say that I do feel that as a designer, I have something of a moral obligation to kind of deal with the impact of science and technological developments. So bearing that in mind, I wouldn't say my focus is design as such, rather the evolution of technology as a whole. Certainly don't see myself as a sustainable designer, which I have actually on occasion been labeled, but I do believe in design with a conscience. I believe that designers should be aware of the world around them and the consequences of their actions, also looking towards the future. I must add that this is something that I think designers already do, and it's part of their DNA. But in my case, I choose to touch upon issues such as sustainability, biotechnology, and psychology directly as a means to reflect and comment upon society, both now and in the future. And I would say that this is essentially the core of my work. So exploring the potentials for technology, and I must say by technology I mean both old and new. My aim is to generate fresh relationships between function and behavior, thus questioning common codes of conduct. I must say that with design, I think it's kind of the beauty of working with product design as a medium. A product can be confronting in a way that perhaps a sketch or a video can't be. It's essentially asking you directly, am I something that you want? I was recently asked by some students exactly how my work involves environmental awareness. And I would have to say that I think that my work tends to tackle environmental issues in a different way than just creating more sustainable products. While developing new sustainable solutions is clearly something that's very important, I think it's at the core of it all, it's societal behaviors that are the cause of our problems, and it's important to try and challenge this head on. So this might well come about by proposing or developing concepts or objects that directly challenge or alter our behavior, such as is the case with the lateral lamp that I'll come to later. However, I would also suggest that another approach might be to plant the seed of an idea inside someone's head, making them consider the consequences of their actions. This is, I guess, a more slow-burning method, but it's essentially the approach I took with the blood lamp project, which again I'll come to shortly. It's also a question that links to something I've been thinking a lot about lately, which is essentially, who would you say has more influence? The person who creates these products that infiltrates everybody's everyday life, or is it the person who influences the thoughts and minds of scientists, designers, and people alike? I have to say I'm not sure I've got an answer for that yet, but I think given the impact of the recent Arab Spring, I don't really doubt the significance of the latter. So, as highlighted in the Arab Spring, I think technology can be a driving force for change, and as it evolves, we also evolve. I have to say I agree with the writer Kevin Kelly when he refers to technology as being the seventh kingdom of life, branching off as a kind of extension of the human mind. In that sense, as Kevin Kelly says, humans are both master and slave to technology. Therefore, we will always be conflicted about technology and find making our choices difficult. In essence, the greater the promise of technology, also the greater the danger. And I think taking that into consideration, it's important then to view the potential impacts, whether positive or negative, of these technologies as early as possible in their development. And this is where I think design actually has a key role. Now, I've saying the word technology a lot, as you probably noticed, and I should probably point out that I'm actually incredibly low-tech with the way that I work. In fact, I don't even think I'm smart enough on a technical or engineering level to kind of deal with that dirty side of technology. But I do think that this naivety gives me something of an advantage. It makes me skeptical and yet inquisitive at the same time. So essentially, I want to know, why would I want this, and what does it mean to me? So today I'd like to share with you two of the projects which I'm showing here in the Boymans Museum, both Lacho and Blood Lamp, and explain to you a little bit behind my thinking and the process of the projects. So first up, I'll start by showing you Blood Lamp, which is actually the first project that I created when I was at the Masters at the Design Academy. In fact, it was very early on in my Masters. And the project actually began as a material investigation, where I started out looking at chemical batteries and looking at the pros and cons of that material. And of course, the widespread use of batteries has led to various environmental concerns, including toxic metal pollution due to the composition of heavy metals such as lead, mercury, and cadmium. Now, while researching into the electrical potential of chemical energy, I tended to move away from that and more towards bioluminescence and chemiluminescence, sort of more natural ways of creating energy. Chemiluminescence, for those who don't know, is of course the emission of energy as light via chemical reaction. Bioluminescence is therefore chemiluminescence that actually occurs within nature itself in living organisms. So you probably are already aware of this from species such as fireflies, which you can see here, or glowworms, jellyfish, certain species of fungi, just to name but a few. The other thing I would say is that there's also been a lot of buzz in the last few years within genomics centered around creating these bioluminescent microbes. And I must admit that that was tempting, but I wasn't particularly interested in that because I felt it was a bit of an easy direction. So whilst looking into chemiluminescence, I actually stumbled across something else which I found quite interesting. And that was luminol, which is a chemical that's commonly used in police forensics, and it's used to determine the presence of blood in crime scenes. So essentially what they do is they take a squirty bottle like you use for your plants, and they can squirt it onto what they think is a trace of blood, and if it is real blood, it will react with the iron found in hemoglobin, and then you'll start to emit a blue glow. So this actually got me thinking, what if power came to the cost to the individual? I don't know if you know this, but the average American consumes 3,383 kilowatt hours of energy per year. To put that into some sort of context, that's equivalent to leaving the light on in 4 rooms of your house for a whole year. Obviously, the simple flick of a switch allows us to power appliances and gadgets 24/7, but then there's no thought to where it comes from and the cost of the environment. Now, ordinarily, this is where I'd like to jump to explaining the project itself, but given that I've been given the opportunity to talk today, I'd like to go somewhat more into the process and explain a whole chunk of the project that I never get a chance to explain, namely my quest to get hold of blood as a source of power. Bloodletting is one of the oldest religious and medical practices, and is still practiced today, such as on the Day of Ashura, which is commemorated by Shia Muslims as a day of mourning for Hassan ibn Ali, I think I said that right, the grandson of the Prophet Muhammad. Bearing this in mind, I didn't imagine it'd be that difficult to get hold of blood, particularly my own. Now, I could have just bought a syringe and kind of tried to siphon off my own blood DIY style at home, but actually, apart from the fact that it's a little dangerous, I didn't really want to do that because I thought that it'd be interesting to go through the appropriate channels and just see how they would react to my proposal. So first of all, I did try going to the doctor, but all he did was sort of smile at me, tell me he liked the idea, and then rob me of 25 euros. So instead, I decided I'd go to the San Quinn Blood Bank and see if they might be able to take it a bit further. And actually this was much more promising. While they didn't actually say yes to my request at first, they also didn't say no. So we started some initial health checks. Actually, I needn't have bothered. Despite the fact that I had a clean bill of health and was, and I quote, like a perfect candidate for blood donation, there was a bit of a problem. As I was British and born in the UK between 1980 and 1992, the blood bank said they were not able to take my blood due to a risk of Creutzfeldt-Jakob disease, which is more commonly known as mad cow disease. Hence, the blood bank were not even prepared to take my blood, let alone give it back to me. Interestingly, while all of this was going on, I was also kind of having a bit of a discussion with the Design Academy to get permission to be able to do testing and also present my project with blood in the academy. But actually that just received a complete no. So ultimately I was forced to begin testing at home, albeit in the shed at the bottom of my garden in the middle of winter. I had actually managed to finally get hold of some animal blood from an abattoir in a town close to Eindhoven. Actually I asked for 1 liter, they gave me 5. I wanted to use, I think in the end I used about 300 milliliters, so that kind of made for an interesting evening because, well, the majority of it had to go down the drain, as usually you would give blood to a medical waste disposal agency, but they'll only take it if you've got more than 5 liters. I had less at that point. So of course I'm kind of running out in the middle of the night, throwing it down the drain, and you'd be surprised by how many people walk their dog at that time of the day. So yeah, that was kind of an interesting evening. But I think as the image here illustrates, I was able to achieve a fairly intense glow from just a few drops of blood, albeit that the glow would die off fairly quickly, so it would last for around 12 to 15 minutes in total. So I think what this process demonstrates is that attempting to use blood as a material is not something to be taken lightly, and neither is it really a viable source of energy. However, what I do think blood does as a material is that it challenges our perceptions on energy consumption by relating energy to both a physical and personal level. And so based on this chemical reaction, I developed Blood Lamp. So by creating a lamp that can only be used once, the idea is that the user must consider when light is needed the most, forcing them to rethink how wasteful they are with energy and just how precious it is. So for the lamp to work, as you can see, the person using it takes the cap off the top so that the powder dissolves in the liquid below, and then the chemical's ready to go. You break the top off, and then basically what you do is you use a serrated edge to cut your thumb or another finger, and then you drip blood into the chemical below. And that blood basically powers a simple light. So in the case of the lateral project, the process is somewhat different, though the aim to question behavior is essentially the same. The lateral project was originally created as an entry to the Nano Supermarket competition, which was held by Next Nature, and the brief was to translate current nanotech trends into visionary speculative products that would stimulate discussion and debate on our nanotech future. Now, for those of you who have no idea what I've just said, the field of nanotechnology is the manipulation of matter on an atomic and molecular scale. That is, operating with dimensions and tolerances of less than 100 nanometers. To put that into some perspective, a human hair is about 60,000 nanometers in diameter, while a DNA molecule is about 2 to 12 nanometers wide. So we're talking extremely small. Now, interestingly, my initial focus with this project was not so much on algae, but rather phytoplankton, which is the photosynthesizing microscopic organisms that inhabit the upper layer of almost all oceans and bodies of water. And during my research, I was intrigued by the change of scale from nano to human, and how transformations on one level would dramatically alter the other. So, for example, silver has long been known as an antibacterial agent. However, on the nanoscale, silver is even more potent and has subsequently found its way into products such as food packaging, children's toys, washing machines, detergents, etc. And that's just naming a few. In the case of phytoplankton, I'd actually read how nanosilver posed potential dangers to the ocean ecosystem, as scientists did not yet really understand how the nanosilver would react with the natural ecosystem when it was released into the water supply. And in fact, in laboratory tests, nanosilver had actually, in some cases, fried the brains of zebrafish. So algae, being one of the most common types of phytoplankton, was potentially at threat. And this is essentially where my interest in algae began. Algae, as you probably well know, has long been cited as the next superfuel due to its high concentration of lipid oils, which contribute about half of the algae's composition by weight. Scientists have studied this oil for decades as a key ingredient in the production of biofuels, creating a fuel that burns cleaner and more efficiently than the petroleum it was born to replace. However, almost 3/4 of the sunlight energy that's absorbed by algae is lost before it can be turned into the sugars or starches used to make biofuels. It was around this time, actually, I stumbled across a recently produced scientific paper, which was that in 2010, scientists from Yonsei and Stanford University had pioneered a technique where 30 nanometer wide gold electrodes were being inserted into the photosynthesizing organs, or the chloroplasts, of algal cells, and thus managed to draw a small electrical current from algae during photosynthesis. The image that you're looking at here is a micrograph of the strand of hair. The thin strand that you see in the center that's coiled into a loop is a nanowire. And nanowires can be produced as thin as 50 nanometers in width, which is about 1,000th the width of a hair. So working on a nanoscale offers ubiquitous technology embedded into everything, from electronics to sunscreens and antibacterial socks, to artificial blood cells that might improve our oxygen intake and improve our physical endurance. And in a way, this will seriously challenge our beliefs on what it is to be natural, and it will also allow us to utilize nature's energy resources. So in order to make some sense of this research by the two universities, I actually contacted Wim Vredenburg, who is professor of plant physiology at the University of Wageningen. And Professor Vredenburg has been studying the electrical potential of plants since the 1960s and is somewhat of an authority on the subject. I put the question to him that's shown here. So will nanotechnology alter future energy production? And the suggestion from the research was that there was actually the potential here to generate very low-level energy using living organisms. Actually, his reaction made me laugh. He basically said, "Why would I want to do such a thing?" He said you could draw electricity from a green cell, but then why not just wait for a tree to grow, knock it down, and then burn it? Okay, well, that's a fair point. But he did concede, however, and probably more importantly, that the research that was being done by these two universities was in fact sound, and that theoretically it would be possible to draw electricity from living organisms using this technique. Actually, perhaps more interestingly, Professor Vredenburg suggested that in terms of energy consumption, we can learn a lot from plant life. He went on to say that plants adapt their form to a limitation in function, essentially adapting to local conditions. And you might call that a feedback system of sorts. So a surplus that you might find in a chloroplast might lead to the activation of another organelle inside the plant itself, so the excess would diminish. So simply put, the challenge for me when proposing any design concept based on this research will be to consider how the technology might plug into this existing natural system. So, as advances in nanotechnology lead to increasingly energy-efficient products, plant life such as algae will become much more attractive sources for tapping energy. In the future, it may be possible to power small electrical devices such as by stealing electrons from photosynthesizing algae. Based on my findings, I developed Latro, a speculative product which responds to this research. I'd like to share with you now a short video which kind of explains the idea behind Latro that I've created especially for the exhibition here. So the idea with Latro is Latro, which is actually Latin for thief, incorporates both the natural energy potential of algae and the functionality of a hanging lamp into one design. So by synthesizing both nature and technology in one form, Latro essentially becomes a living, breathing product. Algae are quite interesting because they're relatively easy to cultivate, requiring only sunlight, carbon dioxide, and water, thus offering a remarkably simple way of producing energy. So basically, just to kind of explain a little bit more about the video, the side spout would allow for the addition of more water and release of oxygen, while breathing into the handle on the side of the lamp would provide the algae with CO2. Placing the lamp outside in the sunlight would allow the algae to use sunlight to synthesize foods from carbon dioxide and water. So a light sensor would be needed to monitor the light intensity, only permitting the leaching of electrons when the lux level passes a certain threshold. This way, algae can be tapped for electricity during photosynthesis without leaving the algae malnourished. The energy would then be subsequently stored in a battery, ready to be called upon during hours of darkness. So owners of Latro basically are required to treat the algae much like a pet, feeding and caring for the algae, rewarding them with light. So to conclude, I think what these two projects illustrate is that there is a growing trend towards designers linking more with scientists and other experts, but that relationship is not exactly easy. What I believe myself and other designers offer, however, is the ability to look beyond the basic implications of new or existing technologies. I think in relation to the two projects that I've just shown, I hope to bring the topic of energy down to a human level, to explore how a change in the basic interaction between people and objects might lead to a change in mindset. And this ultimately a change in mindset that will have the greatest impact upon our habits of energy consumption. Thank you.